All right, guys. I hope this matrix stuff is I hope you're finding this matrix stuff to be fairly easy. Hopefully, using the calculator, it's not so bad. I know when you throw variables in there, it gets to be a bit of a pain, but that doesn't come up very often. We just did it on that one assignment that had the variables. Usually, you're just dealing with numbers. So, a quick review: we've covered adding and subtracting matrices, scalar multiplication. That's the one that's just like the distributive property. Matrix multiplication, that's the one that's really stinky, but if you have a calculator, it's not so bad. And then you did a worksheet where it kind of mixed some of these together in the same problem, so a mixture of these operations. So now we're going to learn a new operation that's sort of unique to just matrices. It's not a math operation that gets used anywhere else except for matrices. The name is determinant, or you say find the determinant of a matrix. So determinant. Wow, that's a funny M. Determinant. Okay, determinants can be performed on, as I said, only matrices, but specifically only square matrices. So a square matrix is one that has the same number of rows as it does columns. So 2 by 2, 3 by 3, 4 by 4, that sort of thing. We're going to limit our discussion to just 2 by 2 and 3 by 3. When you get to a 4 by 4, you're getting to where it takes maybe a whole sheet of paper just to do one determinant. But 2 by 2 and 3 by 3 are fairly easy to work out. So as far as the notation goes, every new operation has its own notation: plus sign, minus sign, times, powers, things like that. So let's just do a 2 by 2. If you're given, I'll be just generic here, A, B, C, D. That's a given matrix. There's two general notations for determinant. The most common one is what I'm going to write first, and it's basically you replace the brackets with straight lines, and it looks kind of like an absolute value, to be honest. A, B, C, D inside straight lines. So what I have here doesn't say matrix A, B, C, D. It says determinant of the matrix A, B, C, D, or just determinant. The second notation, which isn't as common, you still use the brackets for your matrix A, B, C, D, and then you write the abbreviation DET in front of it, and then that's like saying take the determinant of A, B, C, D. And again, this could be for any size square matrix. So you could have a 12 by 12 matrix and still do the determinant. It's ridiculous, but it could happen. So what we need to do today is go through the nuts and bolts. How do you do this thing called taking the determinant of a matrix? So if you look at the worksheet that's prepared, we start out with 2 by 2, then get into 3 by 3, and then the answer key. So it's not lengthy. It's just a little practice to get you accustomed to this idea. So I'm going to do example 2. Then I might come up here and write some more notes. Maybe that might make sense to do that. So here's how you take the determinant of a matrix. You multiply the diagonals. Multiply downward like this. -5 times -5 equals 25. Then you multiply the diagonal upwards. -5 times 4 is -20. The determinant is 25 minus -20. So bottom minus top. When you minus a negative, it actually turns to plus a positive, and the determinant here is 45. So number 2 should be 45, and there it is. So let me go back up to the notes here. I'll use this one. So you do the downward diagonal, A times D, the upward diagonal, B times C, or C times B, however you want to say it, and then subtract them. It's bottom AD minus top BC. Now, if you try to you could remember this as though it's a formula, but it's not very convenient to try to memorize it as a formula. If you just learn it more as a method, downward diagonal, upward diagonal, bottom minus top, that's probably going to be the easiest way to go. And with a little bit of practice, you should sort of catch on. You're not going to memorize this for the rest of your life, but as we're learning about matrices and we use this to do other things, it'll be sort of in your memory. You can have notes to look back at. You can pull these things up on Classroom if you need to. Okay, so number 4. Find the determinant. I don't want to use the highlighter. Multiply downward. -5 times 1 is -5. Multiply upward. 4 times 4 is 16. The determinant is -5 minus 16, bottom minus top, and that works out to be -21. So number 4, negative 21. So far so good, right? It's pretty simple. The math you're using is multiplying and subtracting, and you have to, keep track of positives and negatives a little bit. So well within your capability as far as the math you're doing. The process itself, like I said, is new. Downward diagonal multiply, upward diagonal multiply, bottom minus top. Now a 3 by 3. So this is where it gets to be more challenging and maybe more frustrating. So here there are two methods for doing a 3 by 3 determinant. One method translates to 4 by 4, 5 by 5, any matrix, but it's really complicated and hard to explain. The other method's pretty simple and straightforward, and honestly it's a lot like this method, but it only applies to 3 by 3. Since we're not going any higher than 3 by 3, I'm going to show you the easier method. So here goes. The first thing you need to do is copy the first two columns outside the determinant bars. I almost said absolute value bars. So you're basically just copying those two columns here and here. And you got to try to be neat and line things up and don't get way out of scale. Try and keep everything fairly decent in line. I'm going to change colors here because it's going to get a little funky. So if I say multiply your diagonal downward, I'm going to multiply all three of these numbers together. Negative 3 times 4 is negative 12. Negative 12 times negative 1 is positive 12. Then I'm going to do this downward diagonal. Negative 3 times 5 is negative 15. Negative 15 times 5 is negative 75. You go plus negative 75. Then this downward diagonal. Negative 3 times 1 is negative 3. Times negative 1 is positive 3. Then you go plus positive 3. Add these together. 12 plus negative 75 is negative 63. Negative 63 plus 3 is negative 60. And if the mental math screws you up or anything, just grab a calculator, pull up Desmos, type this in. All right, now I'm going to do the upward diagonal. 5 times 4 is 20, times negative 3 is negative 60. Negative 1 times 5 is negative 5. Negative 5 times negative 3 is positive 15, so plus positive 15. Negative 1 times 1 is negative 1. Times negative 3 is positive 3. Add that together. Negative 60 plus 15 is negative 45. Negative 45 plus 3 is... I feel like I've made a mistake. Let me go back and double check my work. Negative 20 times 3 is negative 60. Positive 15, positive 3. No, that's right. Negative 45 plus 3 is negative 42. So now, it's like what we did in the 2 by 2s. We need to do bottom minus top. Bottom minus top. Of course, we need minus a negative. It turns into plus a positive. Negative 60 plus 42 is what? Negative 18. Wow, I'm feeling really insecure on my mental math. Let me go check number 6. Oh, all right, good. Negative 18. All right, I had a little shaky confidence thing going on there because, this many numbers, doing mental math, multiplying and adding and keeping track of positives and negatives, yeah, freaked me out a little bit. But that's it. So the method is, you can't say the same, but similar. You have to do downward diagonals, upward diagonals, and then subtract bottom minus top. But when I just say downward diagonals, in a 2 by 2, there's just two diagonals, one here and one here. A 3 by 3, in order to make this process work, which honestly is pretty just random as far as you're concerned, right? What's a determinant? I don't know. Just a thing you do. Yeah, it just seems kind of random, but the method to make it work involves copying these two extra columns out here. So then you have 3 downward diagonals, 3 upward diagonals. You add the products that you get, and then when you're done, you subtract. So lots of steps, lots of things to sort of get lost on. We'll do another one. I'll try and go through it slowly. I'm not going to write all over it quite as bad as I did this one, and see if it makes sense. Okay, so we're going to find this determinant, 3 by 3. What's the first step you need to do? Copy the first column and the second column out here. Good. The general flow, downward diagonal, upward diagonal, and then do bottom minus top. So that's what we're going to look at here. Let me change colors. I like the way the red stands out when I do this. So downward diagonal here. Negative 2 times 1 is negative 2 times 4 is negative 8. Negative 2 times 4 is negative 8 times negative 2 is positive 16, so that's plus positive 16. 4 times 1 is 4 times negative 4 is negative 16, so plus negative 16. Then the upward diagonal. Negative 2 times 1 is negative 2. Negative 2 times 4 is negative 8. Negative 4 times 4 is negative 16. Times negative 2 is positive 32. 4 times 1 is 4. 4 times negative 2 is negative 8, so plus negative 8. Okay, so if I add these up, well, luckily those cancel out. I get negative 8. If I add these up, negative 8 plus 32 is negative 20, is positive 24. 24 plus negative 8 is 16. Bottom minus top. Negative 8 minus 16 is negative 24. Let's see if that's right. Oh, thank goodness. Nothing better than working one of these things out, doing all this work in front of a whole class, and then turns out you're wrong because, you know, way back here you got the wrong sign or something. But yeah, that's it. So look, not a super lengthy assignment. Just sort of getting your feet wet in this idea of the determinant. You're not learning it for nothing. Mathematically speaking, determinants have a broad range of uses in various areas of mathematics and engineering and science in things. How many of you are really going to concern yourselves with that? Well, that's debatable. Let's not get into that. But for us, it's a skill or it's an operation that we're learning, just like adding, subtracting, multiplying, that we can use in future contexts as we go through pre-calculus. So that's it. Do the work, odds, check your answers, show your work. Let me know if you have questions, and good luck, and talk to you later. Bye-bye.